Bismillahirrahmanirrahim. Assalamu alaikum. This is our introductory lecture about chemical bonding. We will discuss today nature of chemical bond and concept of chemical bond and Lewis diagram in this session. A chemical bond is a force or an interaction that accounts for the association between atoms in a molecule or in ions or in the form of crystals or some other stable species. So you can say that a force or an interaction that holds the atom in a molecule is known as chemical bond. A chemical bond is a force that holds the two atoms together, in the form of molecule or in the form of ions, in the form of crystals, and some other stable species. You can see in your daily life various examples of chemical bond which are present in different elements. Like this is an example of table salt. The formula of table salt is sodium chloride. In this case, you can say that the sodium chloride, there is a bond, a force between sodium and chlorine ion. Sodium ion and chloride ion, there is a force that holds these two ions together. That force is known as a chemical bond. In this case, this force is developed when an electron is transferred from sodium to chloride. So that is why this is termed as a chemical bond, a type of chemical bond known as ionic bond. Similarly, you can see another example from your daily life, that is oxygen molecule. Oxygen exists in your atmosphere approximately 21%, and this shows that it is highly stable molecule. In this case, the two oxygen atoms, they are held together by a force which is known as a chemical bond, a type of bond, a type of force which is developed due to sharing of electron from one atom to another atom. So that is why you will see that the oxygen molecule has a covalent bond, or a force that holds these two oxygen atoms together. A bond from chemical bond, you can see another example of your daily life, the water molecule. Here is the formula of water molecule, H2O. In this case, you can see the chemical bond, a force between oxygen and hydrogen. And this chemical bond or covalent bond is developed when electron from one oxygen and another electron from hydrogen is shared on one side, and same is from the other side. So you get this stable molecule, which is water. You know, the water is a very stable species, very stable compound, which is present on Earth. It is plenty of water you can see on the Earth. It is an example of chemical bond, which is polar covalent bond. Here, this is non-polar covalent bond. So the chemical bond is a force that holds the two atoms, the two ions together. So you can say that a chemical bond is an interaction that accounts for the association of atoms into molecules, ions, and crystals. In order to represent the molecule and the structure of molecule, you should know that how the Lewis diagram is represented. Lewis diagram is a graphical representation of elements and their valence electrons. In very simple words, you can say that Lewis diagram is a graphical representation of the structure of the molecule, which shows that which valence electrons are available and which valence electrons are involved in bonding. So how you will draw the Lewis diagram? The first thing you should know that is the number of valence electrons in each atom in the molecule. So this can be determined by the periodic table. From alkali metals, they have one valence electron. Alkaline earth metals, they have 2 electrons. And onward, you can say boron family with 3, carbon family with 4, nitrogen family, here is oxygen family, and then halogen has 7 electrons. And in noble gases, they have 8 electrons. So you should know the valence electrons in each element. The first thing you should know is the valence electron of each element in the molecular compound or ion. And then you have to add all these valence electrons. Here, you can add or subtract electrons only for ion, not for neutral molecule. For example, for nitrate, it is negatively charged species. First of all, find out total number of electrons and then add 1 for the -1. And first of all, we have found total number of electrons for hydronium ion. Here are 9. And subtract 1 for positive charge. In this case, nitrogen has 5 valence electrons and there are 6 valence electrons in oxygen. For 3, it is 3 into 6 and you get 23 plus 1, 24 electrons in nitrate. Similarly, hydronium ion, you will get that 3 hydrogen has 3 electrons, whereas 1 oxygen has 6 electrons. So it has total 9 electrons. And for positive charge, we subtract 1. So overall, hydronium ion has 8 electrons. And you should also know the standard symbol of elements. You know the single and double covalent bond. You should know the octet rule. And then you can draw the Lewis diagram by using all this knowledge. And any electron which is left over is kept at central atom. So these are the rules or steps to follow for the Lewis diagram representation. Here is some example. In case of water, we have 2 hydrogen and 1 oxygen. Each hydrogen has 1 valence electron and each oxygen has 6 valence electrons. So this is central atom. It is placed over here. We have 2 hydrogen on both sides, forming 1 covalent bond. Here, 1 covalent bond, it is shared with oxygen and hydrogen, between oxygen and hydrogen on the other side. So you will see that the two pair of electrons are still remaining on water molecule. So this is the Lewis diagram for the water molecule. Similarly, you can draw it for SO3, sulfur trioxide. Here is the structure of sulfur trioxide. Sulfur and oxygen belongs to the same family. That is why they have 6 electrons each. 3 oxygen gets 18 electrons. So overall total electrons are 24. And if you can see the 2 electrons over here, 2 electrons over here, and 2 electrons over here. So it means that 2, 4, 6 electrons are involved in bonding, single bonding. So -6, it means 18 electrons after involvement in bond formation. 6 electrons are involved. 18 electrons are still there in valence shell. And as you know that each oxygen has 6 electrons if it is forming single bond. So it gets negative charge. And if we do not write over here, say double bond, we can write that each oxygen has -1 charge and sulfur has +3 charge. So this is very unstable condition. The stable condition is that each sulfur and oxygen forming double bond. And this shows that sulfur do not follow here the octet rule. It is somewhat violation. It is due to the expansion of orbital in the S. So here sulfur will form 6 bonds and you will get this type of structure. I have given you 2 examples. One is in which the octet rule is followed. Another one in which the octet rule is violated. Violation is due to sulfur, which can expand its electron. So Lewis diagram can be drawn in this way. What is octet rule? It is tendency of atoms to prefer to have 8 electrons in its outermost shell. In this case, sodium has 1 electron in its outermost shell. If it is transferred from sodium to chlorine, then its previous shell will have already 8 electrons, and it means that it has completed its valence shell. Octet rule is followed. And if one of the electron is transferred from sodium to chlorine, chlorine already has 7 electrons. If it gets 1 electron from sodium, its octet is again completed by the gain of electron. So that is why a bond is formed by the transfer of electron to sodium, and the octet rule is also followed. Similarly, you can see the transfer of two electrons from calcium to oxygen, and two bonds are formed between calcium and oxygen. Bond is also formed by the sharing of electron. That sharing will also satisfy both atoms in such a way that it will fulfill its octet. It will also fulfill its octet. So in this way, the carbon, which has 4 electrons in its outermost, it will share its 4 electrons with this one, 2 oxygen on both sides, and will you can say that it will have 8 electrons in its outermost after sharing. Similarly, oxygen needs only 2 electrons. So after sharing of these 2 electrons, so it is also satisfying the octet, the octet or the valence shell. So that is why octet rule is followed even if the electrons are shared or if they are transferred. So a bond is formed between the two atoms either by sharing or by transfer. So here is an example, another example of covalent compound, that is ammonia molecule NH3. In each case, nitrogen is sharing its 1 electron with each hydrogen, 3 hydrogen, forming 3 covalent bonds. They still have this electron pair. So you can say that octet rule is again followed because nitrogen requires 3 electrons. These 3 electrons are shared by 3 hydrogens. So, in conclusion, we can say that an ionic bond is formed by the transfer of electron from electropositive metal to halogens or to electronegative element to non-metal. So that is why an ionic bond is formed. A covalent bond is formed. A covalent bond is formed by sharing of electron between two atoms, and that sharing is very useful and it will satisfy the octet. So these are also the Lewis diagram representation of carbon dioxide, water, and nitrogen. So this is the end of the lecture.